Okay, so let me proceed. Okay, so now we calculate the amount of air, meaning that air mole, number of mole of air. So we got, that is, the answer should be 0.595 kilomole. So since we know the molecular weight of air, that is, always remember that molecular weight of air, that is 29. So mole times molecular weight. So we go, that is the formula, actually n equal to m over molecular weight. So n we know, so n we have calculated, and molecular weight we know, so we calculate the mass. So that is 0.595 kilomole times 29, that is the mass. So what, so that is actually we want to calculate. So again, doing the revision from the beginning. First, based on the informations given, the sulfur weight percent and fuel. So we found first the amount of sulfur. Then when we do the amount of sulfur, then we calculate the amount of sulfur dioxide. That is uh, the amount of sulfur divided by molecular weight of sulfur times the sulfur dioxide molecular weight. So we calculate the amount of sulfur. Now, if we want to calculate the amount of air, then we refer the equation that sulfur, we found the first the number of moles of oxygen. And once we calculate the number of moles of oxygen divided by percentage of oxygen in air, we know that is 21%. Then that is the uh, molar number of moles of air we calculate. And after calculation of number of moles of air times the molecular weight of air, that is 29, we calculate the mass. Actually, our formula is very easy formula, that is n equal to m over molecular weight. And another thing, as Alexandra told, that since by the information here we can calculate the number of moles of sulfur, but since the equation we know that 1 mole of sulfur, 1 mole oxygen, so the moles number will be the same. That is the very important things we have to know. So number of moles of sulfur and number of moles of oxygen will be the same. So once we calculate the number of moles of oxygen divided by oxygen percentage in air, we calculate the air mole. So if we calculate number of air mole times molecular weight of air, we calculate the mass of air. That is the answer. Is it clear, class? Is it clear to you? Mira, Amira, clear? Amira, Amira. Okay, so I proceed for next. Now we do a couple of examples. Okay, next. Next equation, please note down the equation first. Emission rate. Emission rate equal to emission factor times flow rate. You write flow rate, it will be for avoiding any confusion. Although it is right like that, emission rate is emission factor times activity data. Actually, activity data is equal to flow rate. Unit of activity per time. Unit of activity, normally it is flow per time. The flow per time, that is flow rate. Please note down this equation. Emission rate equal to emission factor times flow rate. Please note down, everyone, this equation first. Again, I'm telling, emission rate equal to emission factor times flow rate. Now, question is, flow rate normally it is, we will know, it will be given. What is emission factor? It is very simple. Emission factor, you can refer this table. Here, emission factor is given. You have to note down what are the emissions. These are the pollutants. These are the activity process. This is actually two tables given. So whatever we do the calculations normally based on this process. What are the pollutants? For example, process is FCC. pollutants nitrogen dioxide. So emission factor will be 71. But one thing I would like to draw your attention, the emission factor here, you have to, this is the unit, that is pound per 1000 barrel feed. This one you have to consider. For example, in FCC, nitrogen dioxide emission factor will be 71 pound per 1000 barrel feed. Catalytic cracking, aldehyde, emission factor is 12 pound per 1000 barrel. Steam boiler, actually steam boiler, there are two types of steam boilers is given. One is below, capacity is given below, and below 100 M stands for million, BTU stands for British thermal unit per hour. If your steam boiler below 100 MBTU, you use this. If higher MTBU, you use this. But see here, another thing, here is given some units also. You have to carefully use this. Okay. For example, steam boiler less than below 100 MTBU, million British thermal unit per hour. Sulfur oxide, the unit is emission, that is actually not unit, emission factor, that is 142 times sulfur percentage, weight percentage over 100 gallon. So what I want to tell, that it is simple, that emission rate, if you want to calculate emission rate, then you have to find out emission factor from this table, and multiply with activity data, that is the flow rate. You can calculate the emission rate. One example here, see here, one example. See here, first things that 10,000 BPD, BP stands for barrel per day. That is actually the flow rate. Flow rate is given. Containing 4 weight percent of sulfur. Sulfur weight percentage is given. So it's burned a steam boiler which capacity is 80 MTBU, meaning that, see, then we have to calculate this one below 80 MTBU, meaning that we have to refer this one. Okay. So here pollutant is sulfur. So see the sulfur dioxide, sulfur oxide. So we have to use this. These are the emission factor. So accordingly you have to. So see here, calculate the amount of sulfur dioxide emitted from the so here pollutant is sulfur dioxide. So accordingly you get the value of emission factor here. So very simple. So here I have to calculate by using that formula, that emission rate equal to emission factor times flow rate. Flow rate is given. Emission factor, you use this from this table. Only careful with the unit. See here, initially it is given like that 71, so it should be pound per 1000 barrel. So here is given like that. So accordingly you use. So formula is very simple, as I told, emission rate equal to emission factor times flow rate. Emission factor, you get these are the value. Then weight percentage, sulfur weight percent, put this value 4%, and flow rate, put this one. Only careful here. See here is given 142 times sulfur weight percent over 1000 gallon. Here, be careful here. Given 1000 gallon. So, but this one is barrel. So this one barrel you have to convert to gallon. So 1 barrel equal to, please note down, 1 barrel equal to 42 gallon. So flow rate will be 10,000 for BPD equal to 420,000 gallon per day. Simply put that equation here. Emission factor, this one, this value, put the sulfur weight percentage times this one times the flow rate. Don't confuse with unit because this one is given barrel per day. So you have to convert to gallon. Conversion factor, 1 barrel equal to 42 gallon. Is it clear, class? Ayuni, is it clear to you, Ayuni? Please give me your feedback, please. Ayuni, are you hearing me? Ayuni, are you hearing me? Shafi, are you hearing me? Shafi, Aminuddin.
Yes, doctor.
Aminuddin, is it clear how I explained to do this calculation? Is it clear to you?
Yes, clear.
Okay. Just for your information, can you repeat that? How you can do that? This calculation, how you can calculate the amount of sulfur dioxide? I mean.
So first of all, we refer to the table 17.4 for sulfur oxide, and then there will be two value for the what is it called? Emission factor.
Yes.
One is for below and one is for below 100 MBTU per hour capacity, and one is for the higher than the number. So
but here
since
proceed.
Yeah.
Okay.
It is below 100.
Okay.
So we chose the one with 100 and what is that? 42.
Okay.
Weight percent.
Very
times
good.
The composition of sulfur. 4%, and then the crude feed rate is converted to unit gallon per day.
Why?
1 barrel is equal to 42 gallon.
Why? Why?
What?
Why we have to convert?
Oh, because the emission factor. Because the emission factor is in gallon unit.
Very good, very good. I understood you. Okay, very good. Thank you. Thank you. So I think you can calculate as Aminuddin explained. It's very simple. Main thing, formula. Formula is emission rate equal to emission factor times flow rate. Emission factor you get by using this table. Simple. Okay, that's all. Then we proceed for next. Now we do another also same like that, but just here we have to calculate the trace element. Trace element normally found in the catalyst, because you know when catalyst doing some catalyst particulates are emitted to the environment. So formula is like that: ER equal to TSP, weight percentage, over 100 formula. Now, what is ER? ER, that is emission rate. TSP, that is actually total suspended particulate. Total suspended particulate. Weight percentage times 100. This is the formula. Now, TSP is calculated from emission factor and weight percentage of appropriate species. Okay, TSP is calculated emission factor time weight percentage of the appropriate of that species. Okay, now see, normally Here is two things is given, trace elements. Here another thing, refer, see here is given already in weight percentage. So here one is FCC. FCC stands for fluidized catalytic cracking. Another one is fluid caulking. So here are the some pollutants given. Trace element, not pollutants, trace elements. Nickel, manganese. So these are the value. This table you have to refer to do the next calculation. Here, see here, 10,000 BPD. Okay, you can read this. So we have to find out the amount of particulate to the atmosphere, and we have to calculate the amount of nickel. So see here, nickel percentage. So we have to take directly from here nickel, because we have to calculate the nickel amount in the part. So two things we have to calculate here. One thing, amount of particulate whenever the catalyst loading in FCC unit. So first things here, again, here is given the flow rate, 10,000 BPD. So again, this table, we can get the emission factor. So emission factor. So our process is on that calculation, that is FCC, meaning that catalytic cracking, fluidized catalytic cracking, and our pollutant was particulate. So the emission factor we have to take out from this 242. Again 242. After that you have to write this unit, because 242 pound per 1,000 barrel. Okay. So first things, emission factor, we got the emission factor from this table. Then now we have to calculate the emission. Here is the volumetric flow rate is given, and emission factor we have calculated. So now we can calculate the amount of catalyst of emission feed, because feed is volumetric flow rate is here. We have calculated, we have taken the emission factor. So emission factor times the flow rate, we calculate the emission rate. So after that, then again by referring this table, we got the nickel weight trace element weight percentage is here. Weight percentage is 0.88. So after that, so we refer this equation, that emission rate will be these things, the trace element total suspended particulate matter. So here 0.88 over 100 times the whatever we got the value using that 10,000 times the emission factor. So we can calculate the amount of nickel. So I just proceed a bit fast, but I think I explain you. You please go through the exam. As I told, that for that you have to refer this table. The value will be the given. So simply main thing, the equation, as I told, the first equation you have to remember that emission rate will be emission factor times flow rate. Then emission factor, refer that table, whatever that is. Then you proceed this calculation. I think since I cannot show you here in the board, so it is I explain you. I think please go through your book in page number 431. You can see that, and I think it will be clear to you. Just go through that page. Please note down page number 431 in your ebook. So solution is there. I think it is very simple. I think you can do that. Whatever bit complex, we will, because in future, after that some calculations we have to go through again one by one. Then I think these things no need to spend more times. It is clear to you. Am I right, class? Is it clear so far? Class? Manjula? Manjula?
Yes.
Yes, doctor.
Okay, it's clear, right? Right? Clear so far?
Yes, doctor.
Okay, good. Let me proceed for next. Okay. Okay, so now how to calculate the stack and flare emission, stack and flare emissions. As you know that flare, as I told, that here all the gases accumulated and burned. So there is a combustion occurring. So here these are the complete combustion, the equations. Methane react with oxygen, produce carbon dioxide, ethane, and propane. Three things, three hydrocarbons of, shows here complete combustion. And for incomplete combustions also is produced. Normally, as you know that if complete combustion produce carbon dioxide, incomplete combustion produce carbon monoxide. Okay, so these are the equation. And another table here, typical constitutions of the flare gas. So here, see here, two things, two values are given. One for high pressure value, this is HP, P stands for pressure, high pressure, mole percentage given, and low pressure, that is the mole percentage is given. C1, that is the CH4, C2, that is ethane, C2H4, C3, that is propane, C4, butane, 5, that is pentane, you know it, 6, benzene, 6 hexane. So here, see, hexane almost 0, but from C1 to C5, there is a mole percentage are given for high pressure flare and for low pressure flare is given. From flaring, emission factors also given, some gases, CO2, CH4, and other gases, that is the volatile oxygen compounds, you know. So these are the value given. But here, see, refer the unit. For example, CO2, emission factor 2690 kg per ton. Okay, accordingly you have to write. CH4, that is 35 kg per ton. So now, see, for doing this calculation, we will do this calculation now together. See here, first things given the flare gas flow rate. Please read this. Okay, read this. I want to tell you here. Another thing, high pressure. See here, I told one is high pressure, another one is if high pressure, then you refer this. If low pressure, you refer this. So high pressure, here is high pressure. So here we have to, here is given, flow rate is given, mass flow rate actually, because it is kg per hour. Mass flow rate is given. So composition, you refer this table, composition, these are the composition, table will be given. So assuming complete combustion, so we have to refer that these things, these are the complete combustion. Calculate the CO2 emission, CO2 emission. And based on material balance, actually these are the composition of material balance of the gases from C1 to C5. And after, by using this composition, we will find the CO2 emission rate, and after that we will compare with this. Actually, CO2 emission rate, since emission factor is given here, by using this knowledge, whatever we have learned so far, I told that emission rate equal to emission factor times flow rate. So here flow rate is given. Flow rate is given in this question. Flow rate is given 100 kg per hour. So, and emission factor also is given, that is 2690. So directly you can calculate emission rate. Am I right? Ariana?
Yes, doctor.
Am I right? Since here given the emission factor and you know the emission flow rate, can we calculate the emission rate? Ariana? Ariana, just now I talked with you. Ariana, please come again. Shafida, Shafida,
Yes, doctor.
Shafida, since
Yeah.
here emission factor is given and
Ah.
flow rate, you know, can we calculate emission rate?
Can, doctor.
How?
Right.
How
Initial rate equal to initial factor times flow rate.
Good, very good. So see here, emission rate given 2690. But one thing, you have to put the unit is like that, huh? Kg per ton, huh? Hello, Safida.
Yeah. Yeah.
2690 kg per ton, huh? And you know 1 ton equal to 1000 kg, huh? 1000 kg. Okay. So 2690 kg per 1000 times 100, because this is flow rate is given 100, right? Right? So, okay. So it is clear by using because it is CO2. So CO2 emission rate is given here, flow rate is given. So directly you calculate the emission rate. But question is asking that emission rate, carbon dioxide emission rate, you have to calculate based on material balance. So whenever do like that, so we have to calculate based on by using these things one way, and another way we have to calculate based on material balance and then compare by using, this is carbon dioxide emission rate by using emission factor, and here by using material balance, molar composition. So molar composition now it is directly you can calculate first the gas, the total gas molecular weight you calculate. It's easy. That point molar percentage is given, that is 0.728 times CH4. CH4, that is the molecular weight of CH4, that is 16, plus this one times ethane. Ethane molecular weight is 30. Then 0.063 times pentane, propane. Propane molecular weight is 44. Then this one times butane. This one again butane. This one is pentane. 0.004 times the pentane molecular weight is 72. Plus 0.005 times 70, again 72. For C6 no need, because it is 0 times, so it will be 0. So you calculate first the total molecular weight of that gas. Then, so it will be kg per hour. So once you calculate the mass flow rate, you can calculate the molar flow rate. Molar flow rate formula equal to, please note down this, because we are running out the time. I have to show you some other calculations also. So you calculate the mass flow, you have calculated mass flow rate by using our knowledge, because it is molar percentage is given. So you calculate mass flow rate. So once you calculate mass flow rate, then then you calculate the molar flow rate. So molar flow rate will be mass flow rate over molecular weight. Formula is simply that is the n equal to m over molecular weight. So molar flow rate you calculate. Then you again by using our knowledge based on mass balance equation, that is the molar flow rate of total gas times, now because we want to find the amount of carbon dioxide. So carbon dioxide here C1 CO2 in here is only one mole of carbon. In C2 there is 2 mole, in C3 3 moles. So like that, so total mole times the molar percentage again by using this molar percentage time 1 mole here, then molar percentage here times 2 mole. For this pentane you use 3 mole, butane 4 moles, pentane 5 moles. So you calculate the total amount of carbon dioxide molar flow rate. After calculation of molar flow rate, you know carbon dioxide molecular weight is 44. So molar weight, again formula is simple, same formula, n equal to m over molecular weight. So molecular weight of carbon dioxide 44. So molar weight times 44, you will get the total the mass flow rate of carbon dioxide. So after getting that, you compare this one. This one is very easy, emission rate times molar flow rate. But for using this, you have to just calculate these things. Then you compare. Might be it will be slightly vary because it is using emission factor, but it is using the molar percentage. So like that you calculate. So please again, based on your textbook, as I explained, just simply go through that these things. I think it will be clearer to you. So this is the, so until that, please, I have shown to you 4 examples so far. So based on these 4 examples, please again go through your textbook. I think it will be very clear to you. I'm quite confident. Wherever your problem, I have explained. I have already explained. I think you can guess or you understood so far. If any question, you can let me know, because this answer script you can get it in your textbook, but some portion in the textbook they escape or you may not get the where is it. So as I told that here we will use the main equation, that is emission rate equal to emission factor times flow rate. Again another formula, that is the number of mole, n equal to m over molecular rate. Sometimes we use molar flow rate, sometimes we use number of moles. Formula remaining the same. Molar flow rate equal to mass flow rate over molecular weight. Molar rate, mole, n equal to mass over molecular weight, like that. These are the methods. So as I told that there are some incinerator. Incinerator mean it is almost the same to burn it out, and also some uses the process, what are the emissions. These are the list of emissions. HF stands for hydrofluoric acid, NOx, that is I told that nitric oxide or nitrogen dioxide. VOC, that is volatile organic compounds. So you can refer the slides, it's easy. Now until that, this is related to gas. Now we'll go through for wastewater, because we know that, because in wastewater there I want to show you 2 examples. That is bit tough one, not tough actually. I have to explain you more details. We'll go through that. Okay, so until that, gas waste complete. Now wastewater. Wastewater, as you know that in wastewater, petroleum wastewater, that is may contain halides, chloride, ammonia, heavy metals, etc. So these are the list actually. The oil and grease also may contain. X, only when you see one X, that stands for 50 milligram per liter. When you see the double X, that is in between 500 milligram per liter. If you see triple X, that stands for higher than 500 milligram per liter. For example, in FCC unit, well, in between 500 milligram per liter, but hydrogen sulfide higher than 500 milligram per liter. TOC, another thing, so far we have learned that is volatile organic compounds. TOC, that is total organic carbon, total organic carbon. Another term also DOC, DOC, that is dissolved organic compounds. Please note down these things. VOC, volatile organic compounds. TOC, total organic compounds, total organic carbon. And DOC, that is dissolved organic carbon. Actually, DOC, that is very fine carbons, very fine, 0.2 to 0.7 micrometer, very fine particles, very fine. So that is why it is calling dissolved, DOC, 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 dissolved organic carbon. TOC, total organic carbon. Okay, so here, see here again. One more example here, very short, simple example. I will not go through that. Just for your reference, you can check your textbook. I can easily, you have to refer this table. See here, component toluene benzene, weight percentage of DOC. As I told, DOC stands for dissolved organic carbon. Very fine particles, very fine carbon, 0.2 to 0.7 micrometer. So weight percentage is given, emission factors also given, elements. So by referring this table, you can do this calculation. You can before that there is one more calculation, one more equation, that is wastewater. Wastewater, WWE stands for wastewater equivalent, equal to dissolved organic carbon, weight percentage times 100 times flow. By using this equation and by referring this table, you can able to make this calculation. Very simple, very simple. You refer the textbook. I think it will be easier. As I told, that WWE again, that is wastewater equivalent. DOC, that is the dissolved organic compounds. Value is here. Value is here. So put it here. Simple. Accordingly, take for example benzene value is here. So put it here. Times flow. For example, see here, flow rate is given. Put that, and you can able to get the calculation. Okay, class. Sharanya, are you hearing me, Sharanya? Sharanya. Harni, are you hearing me, Harni?